Okay, so we'll be talking about photoelectric effect. Uh, f- so today, the way we will talk about photoelectric effect is in two ways. We will compare today photoelectric effect. Okay, so photoelectric effect, we will be talking about particle nature and wave nature. Okay, now what do I mean by, we know that photoelectric effect is done with light. How? Let's suppose this is what are these? These are particles, in these are photons, and they hit the metal surface. Metal surface, okay. And when they hit the metal surface, the electrons in the surface bounce off or escape. Let me use a correct word, escape. But depending on a certain condition, on they will escape. If this particle's energy is more is equal to the, yeah, it's equal to the energy of the photon, sorry, electron, then it will escape only. But if the energy of photon is more than energy of electrons wave function, then we get plus kinetic energy as well, meaning that it will not only escape but also bounce off at a higher height. Okay, so this is how particle it will behave by, well, or actually the effect itself is explained in particle nature and it cannot be explained in wave nature. There are certain conditions on why it cannot be done, because when photon hit a particle which is electron, we don't call it electron, actually we call it photoelectron. Photo electron is emitted, but what's the condition on which it's emitted? It's emitted on the condition that photon's energy is equal or greater, sorry, greater than or equal to electron's energy, such that it's in particle nature, in which it, sorry, it will emit instantaneously. Okay, what do I mean by instantaneously? So the word instantaneously means this is the metal, photon comes in, the moment this photon interacts with this electron, point of interaction, okay, the moment it will interact with the photon or electron, what will happen is that energy transfer takes place, energy transfer takes place, and the moment it takes place, electron is emitted. This is electron. Okay, here we will assume that this electron's energy, it has E P plus E K dot E. By EP means energy which is it was absorbed, it absorbed all the energy photon had. So one more key point here is that each photon release one electron only. Okay, so the equation, how could I forget the main equation? E is equal to HF. Also particle nature, also shows that light, discrete energy of light or particles. In particle form, every particle has discrete amount of energy. By discrete amount of energy, we mean it can only occupy uh, to explain discrete energy. I would have to go into energy levels, but even if we don't talk about energy level, we will let's explore what in discrete energy is. But for now, let's stick to the topic, which is about wave nature, like photoelectric effect, of course. So, where were we? Instantaneously, we did. Okay, so what else was there? Uh, because why right now I want to focus on particle nature, and why only particle nature can only allow photoelectric effect to happen, but not wave nature. So, mm, what else could be there that we're missing? E is equals to hf is the main equation. The second equation, which is most important, and it's even in exams it's given, which is hf is equals to hf plus k dot e. By this hf, I mean work function. Let me just replace it to work function. Now, again, yeah, work function. What is work function now? There's some definitions as well which we need to remember. What is work function? This electron over here, okay, this electron over here has work function, okay, and that work function is nothing but the energy which is between this electron and the surface of metal, okay. So what happens of the binding, we can say the binding, of course we can say the binding. So that binding can only be broken if this photon coming in has enough energy to break that bond between the particle and the surface. So that's work function. And we have threshold frequency as well. Threshold frequency is the same as it's in the like in the equation E is equal to hf. We can see that f is dependent on energy. So meaning this photon emitted must have a certain amount of frequency. This which color should I choose? This one must have certain energy. Oh, sorry, frequency. Okay. Now, let's go to another page. Okay. Now, let's talk about. Is this all about wave nature? Particle nature. For now, let me remove wave nature from here. We'll only focus on particle nature. Now, what else could we talk about? What could we talk about is that wave nature. Okay, particle is in particle we have this. Okay, wait. One interesting thing: when we make a circuit, we use this symbol in for the circuit, in which what happens is that these are photons hitting the circuit and on this metal, and the emission of electrons is then used to run this whole circuit. Okay. uh Photoelectric effect was observed by Einstein. That's everyone knows that. I don't have like make emphasize, but Einstein should be mentioned if it's his equation or his effect which was done. And so what actually we're looking at is the specific of the topic is light itself. The discreteness of light, discreteness of energy at quantum level is described here. That, of course, quantum mechanics is in which photoelectric comes in, because we're talking about dual nature of light and which can only be taking place in quantum level, quantum mechanics. Now